Welcome back. In this video, we will discuss the KNNs neighbors algorithm, our first supervised learning algorithm. We will continue working on the iris dataset which we used last time, and this time we will train a KNN on it. So let's begin. After training and testing, we will also visualize the decision boundary of our KNN algorithm. So the decision boundary is basically a line which separates the two classes. So in this picture, the red line is our decision boundary. Secondly, we will plot the Voronoi plot, which basically plots regions around points, which cause other points, new points in those regions to take their label. For example, the blue dot here will cause any new points in this inside this polygon to take blue's label. And lastly, we will look into vectorization using NumPy library. NumPy is optimized to be faster than loops, and the library comes in with many built-in optimization features and broadcasting features as well. I have provided a list of operations and functions on the right so you can use them in your assignments and projects. Here's our dataset. We have a four-dimensional dataset there, which means there are four columns. Now it's difficult to visualize four dimensions, so what we can do is we can choose two columns to work with for this tutorial. I am going to choose the sepal length and the petal length, and let's see if we can find any clusters in this dataset. So there are three distinct clusters for each of our classes, and so I am going to choose petal length and sepal length as the two features we will be working with. So in this cell, we filtered our data frame taking only these columns, the sepal length, the petal length, and the target. Next, we drop the duplicate values, if any, and then we apply the reset index parameter. So what it does is that after you drop some columns, for example, if I drop a row number 1 and 2 from here, our updated data frame would contain rows 0, 3, and 4. So the reset index would update the row numbers as well. And then we split our data set. We take the x, we take the features in x and the target in y. And finally, we apply normalization using the min max scalar. So let's run it and see. Here's our train test split. We obtain a train and test splits. I have done a 60-40 test split, and let's print our shape here. So our training set has 74 points, and the test set has 50 points. Let's talk about the distance functions now. In the iterative approach, we can simply loop over the vectors and perform element-wise operations and sum them up. However, this approach is not very efficient. What we can do is we can use numpy library and treat the vectors p and q as whole and perform operations on them without loops. So let's d- see a demonstration on how vectorized approach is faster to using numpy, and it is much more preferred to use numpy over loops. So here is a short demonstration of loops versus numpy, and we will see how using numpy is faster. So I have two arrays x and y, and they contain 10 million values. So in this approach, I'm going to loop over them and add them up one by one. And then I will print the first five values because there are a lot of values. So it's going to take about 1 minute to perform this operation. It took us 71 seconds to run this loop. Now let's perform the same thing with NumPy. It gives us the output almost immediately in 1 second. So there you have it. NumPy is way faster than for loops because the library comes in with built-in optimizations, and it's perfect for your matrix operations, matrix and vectors operations. Now I'm going to run the KNN for the different values of k over our test data. So it printed the following accuracy. For k is equal to 1 and gave 92% accuracy. As you can see, it gradually increases, goes up to 98, and at k is equal to 31, and then it drops back to 50, drops down to 50. So as we discussed in class, higher values of k will cause the model to get biased. So choosing the value of k is important. So our best accuracy came for the value k is equal to 31. Now let's move on to a decision boundary. In this part, you don't have to worry about the code, because the code will be provided and you won't be expected to write it. So you can simply just observe the plot, the final plot we get. For k is equal to 21, we got an accuracy of 96% for k is equal to 21, and it's going to take a few seconds. Our run is now complete, and here are the plots. On the left, we have the scatter plot with the true labels. So this was the original data set. And on the right, we have the decision boundaries for k is equal to 21. The circles are the points in our training data, and the triangles are the points of our testing data. So here in the white, we have the class 0, and light blue has class 1, and dark blue has class 2. There are some misclassifications like these, but do not worry about these, because we actually got 96% accuracy with k is equal to 21. Next, we move on to Voronoi Tessellation, which basically partitions a plane into regions close to a given set of objects. So every data point X is enclosed in a region, as discussed earlier. We are going to use the Voronoi module from the SciPy, which is also a very popular and important library in Python. So I'm going to use the testing dataset for this, because if I use the training set, there will be a lot of points and the plot would look very messy. So let's run it again. And here are our Voronoi tessellation for iris dataset on k is equal to 1. It is not possible to plot this for higher values of k. So what this tells us, for let's take this point for example, any point inside this polygon will get the label of class 1 held by this point. And similarly, this point will, any point in this box will get this label. Over here we can see these points are almost overlapping, and there's a very few margin, there's a very small margin to move around in this area. Now we can also plot this for the training set. Let's see, it will look very messy actually for the training set. So but anyway, let's check it out. There we go. It's not that bad actually.